let S be the size change such that S of K of ABC is equal to ADE. So the direction is important here. Okay, we are changing from ABC to ADE, which means that this big outside triangle, ABC, is becoming this inside triangle. So looking at that change, is that an expansion or a contraction? That's a contraction. Okay, which tells us what's going to be true about our growth factor. Less than 1, which tells me that the answer you gave me a second ago, Bryce, the 0.67, at least makes sense. Okay, now we'll check it and make sure it's exactly right, but that's a good way for you to kind of check yourself, is say, all right, I got a size change factor of something less than 1. Is this really a contraction? If it's not, then you probably divided wrong. Okay, so what do I do to find a value of K? Divide what? Okay, so I'm going to find a pair of corresponding segments, okay? So a pair of two segments that match up from the new to the old. And I'm going to find those lengths and I'm going to divide them. Now technically you only have to do it with one pair of lengths. I usually do it with 2 just to kind of make sure that both sets come out the same or close to the same. So which set of segments do you want to work with? BC and DE maybe? So these two? Okay. So when I measure BC, I get, oh, old lady eyes are failing me, about 2.7. Do you agree with me? 2.7 centimeters? Okay, and then DE is 1.8. Okay, so remember this was my original and this is my new. Okay, so this is where I started and it became this. So I'm looking for 2.7 times what K value is going to give me 1.8. Which setting it up that way and then dividing is where you get that new divided by old. Okay, and I do believe you're going to get like 2/3, which would be like 0.6 repeating, or 0.67. So 1.8 divided by 2.7, yep. Get like 0.67. If you round it, if you did 0.66, that's fine too. Okay?
Okay, I did it kind of weird. I did A to B, then A to D.
Oh, sure. Yeah. So if you, yeah, you could pick any set of segments you wanted. So you could find, like, yeah, you're using like AD and AB as your corresponding segments, and that's fine too. If I measured those two, I would come up with, oh, like 3.6, 3.7. What did you get, Bryce?
Oh, for AB, I got 2.25.
Maybe you did inches?
Yeah.
Okay. In centimeters, which is fine as long as you do them both in inches.
Yeah.
I got 3.7 here. And then for the whole big one, I got 5.5. So then I would do 3.7 divided by 5.5. Okay, and that time I got like 0.672. Probably just a little slight error in rounding. Maybe this should have been 3.6 instead, something like that. Okay, but still close enough to 0.67 to where that could be my answer. And Bryce, you did yours probably in inches, but still got the same answer, right?
Yeah.
So it actually doesn't matter. I always say measure in centimeters because usually my students are better at measuring in centimeters, but it doesn't matter as long as you do them both the same way. Okay, Jake?
Like, I'm just confused on, like, can I?
Sure, yeah.
Like number 22, like, they give you something with the area, but they also give you a range.
Okay.
Is it as simple as I think it is?
Probably not. Okay. Okay. This is going into the fundamental theorem of similarity, which is the thing we were working on, like, when I left on Wednesday, like the last time I saw you. Hexagon has an area of 90 square inches, and the shortest side length is 5. A similar hexagon has a shortest side length of 4. What is the area of the similar hexagon? So the first thing we need is a K value. Okay? George, you think you know?
Well, it's still the question, but like over the weekend,
Mhm.
I was working on my homework, and like after
because I worked on like quite a bit of this over
Uh-huh.
the weekend. Like after a while, I just kept doing it so much, I actually kind of forgot what to do.
Okay.
And eventually, I started doing like in this case, I did 90 divided by 5,
Okay.
and then I used that, and then I did that times 4.
Probably
I
times
think.
the 4. Okay.
And I don't think that.
That gets you close.
Yeah.
Okay, here's where, so basically what you did, you may not realize it, but you did it like a proportion, okay? The problem is when you're talking about length and area, do you remember we talked about like if you double all the lengths, you're actually gonna get 4 times bigger because you're gonna get bigger this direction and bigger this direction. So it's not quite proportional because you doubled, but your area got 4 times bigger. So there's a different relationship between areas as there is in lengths, okay? So here's what I'm going to do. I'm going to find the K value based on length. You always want to go back to just regular old length for your K value. So I'm going from 5 to 4, okay? So I'm asking myself, 5 times what K value gives me 4, okay? And then to get that, you would do 4 divided by 5, so you would get a K value of 0.8. Okay? So I should be able to take anything in the old hexagon, which is the bigger one, okay, multiply by 0.8, and that would give me my length in my new hexagon. But when you're talking about area, what has to happen to your K value?
It has to be squared.
Has to be squared, okay? Kind of the same idea as doubling, except you're not multiplying by 2, you're multiplying by itself.
Yeah.
Okay? So you have to use that K value twice. So to change my area, I'm going to take that area that I was given up here and multiply by that K value squared. Okay? So George, really what you would have done is just 90 times 0.8 and not 0.8 squared. Like doing it your method, that's the answer you would have gotten. You got to remember to square that.
Okay.
Okay, so 90 times 0.8 squared,
57.6.
yep, 57.6, and that would be square inches. Okay? If that were asking you about volume, what would you do with your K value?
Cubit.
Cubit. Good. Okay. While we're here, how about anything else on this page? What do you want to go over here? Bryce?
Number
20?
20.
Okay. Takes 1 square yard of fabric to make a teddy bear 16 inches tall. How much fabric would it take to make a similar teddy bear 24 inches tall? Okay, so 1 square yard, that's like surface area, right? That's like the outside surface of the teddy bear. Remember to find your K value, I would go back to regular length. So go from this length to this length. So I want to know what K value turns a 16 into a 24. Okay, I want to know what is the K value between the 16 and the 24. Well, I would do 24 divided by 16. I get 1.5 for my K value. And then if I'm talking surface area, what has to happen to my K value?
It's gotta be squared.
Squared, yep, because it's just like regular area, right? So I'm going to take the old surface area, which was 1, and multiply by my K value squared.
When do you have to turn the
It's
yard?
2.25.
2.25. Say it again?
When do you have to turn the yard into inches?
No. Good question. Because here I'm just working with a K value, and the K value would work whether I was measuring in inches or feet or yards or whatever. Like I could turn this into, you wouldn't have to do this, so don't get confused by this, but just as an example, I could say this was 1.25 feet, okay? Or actually, sorry, it would be 1.3 feet, I think. Yeah. So this would be like 1.3 repeating feet. This would be 2 feet. If I did 2 feet divided by 1.3 repeating, I'm still going to get 1.5. Well, if I had typed more 3s, I would have gotten 1.5. So that K value is the same no matter what your measurement system is. And then you can use that measurement. Now, if this was asking you, if this was giving it to you in yards and it wanted your answer in like square feet, then you would have to do a conversion, okay? But as long as you're doing feet to feet, inches to inches, yards to yards, you're okay. Jake?
Like, I'm just kind of confused because for 22 and for 20, I'm getting like to the right spot. Like for 20, I got to 1.5, but I didn't like square it.
Okay,
But like my process is working. Like I don't know.
okay.
I'm just kind of confused. Like
Why I'm squaring it.
why I'm getting like almost the right answer.
Okay.
But not.
You are getting the first step right, is what's happening, I think. You are getting the K value correct. Okay? But then when you go to apply your K value over here, because it's area, you have to square your K value.
Okay.
I think it sounds like that's the step you're
So I
missing.
should just do what I'm doing.
Okay?
And then
Do
if
what you're doing, yep.
It's volume, cube it. If it's area, just square it.
Exactly. Yep. That's exactly right. So it sounds like what you're doing is correct, other than you're forgetting the squaring and cubing. And same thing with George. Okay? What you said earlier. Your process is correct, other than forgetting to square or cube that K value. Okay? Which is sort of an important step. So, try to remember that. But probably in a problem like this, if I were grading this on your test, I would give you 1 point just for finding the K value. I would give you 1 point for remembering to square it, and then 1 point for doing this multiplication right here. So if you forgot to square it, there would still be a lot of other partial credit happening in there. Okay, as long as I could see all that on your paper. Anything else from this page you want to go over? I'll go over any of them you want me to.
23.
23? Okay. 12-inch pizza costs $9.50. It's the same cost per square inch. Now right here, square inch tells you this is what kind of measurement?
Area.
Area, yep. Okay, what should a 14-inch pizza with the same ingredients cost? So first I need a K value. Which two numbers am I using to get my K value? Jake?
Or just be 14 remember.
Yeah, I'm going from 12 to 14. So I'm saying 12 times what K value equals 14. And then, you're right, I would end up doing 14 divided by 12. And I get like 1.16 repeating. Okay. So then, I want to take my cost, the $9.50, and multiply by that K value. What? What do I do to the K value?
Square
If
it.
I'm talking area, I'm going to square it, yeah. And what I would actually try to do, if you can, is in your calculator, if you can keep that original, because if you just do 1.16 and cut it off, your answer is not going to be quite as exact. Probably I would still give you credit if I could see that you did it correctly. But I would take that and square it right in your calculator, so that it uses that whole decimal, and then multiply by the $9.50. Yep. And you get like $12.93. Okay. If you just did one, let's see if I did 950 times 1.16 squared, you get like 1278. So probably I would, if I saw that number, I would know that you did it right. You just rounded that too early. Okay. Is that making sense? What else do you want to see?
Number 14.
Did you get something else,
Yeah,
Jake?
I got 17.6.
Okay, can you tell me what you typed in again?
And then 14 divided by 12.
Uh-huh.
Then I squared that.
Mhm.
And then I multiplied that by 9.5.
Yep, that's exactly what I did too. I don't know how you got 17 point something.
Here you typed it in.
Yeah. Try it again, and if you still can't get it, let me know, and I'll come look at your calculator and see what. Yeah, because what you just said to me was exactly right. Can you say again which one you wanted to see? I'm sorry. Whoever just said one.
14.
14? Okay. Oh, this is just a lot of algebra. Okay, how do you turn proportions into an equation? What do I do with that? How do I write it with the cross products? Something times something equals something times something.
A times D. Wait.
Yep.
Yeah.
A times D equals
B times C.
B times C. Okay, when it says find C, that means get C by itself. So I need to get rid of that B.
Divide by B.
Divide by B, which means I divide this whole thing over here by B. And then this right here is your answer. So you would just write A, D divided by B. Okay. And think about it. If I gave you that and if those were all numbers and I said find this value right here, wouldn't you multiply these and divide by that? That's exactly what I just wrote. Multiply these, divide by that. Okay. What else do you want to see?
13.
13? Okay. So I've got all these coordinates here, and then I want to do a size change of 0.5. What does that mean I'm going to do?
Make it smaller.
Okay, I'm going to make it smaller. What am I going to actually do to my coordinates?
You're gonna multiply by 0.5.
Yep, I'm going to multiply by 0.5. So, like A is at 6, comma 6. So I'm going to take each one of those and multiply by 0.5. Okay?
It actually.
Which is going to give me 3, comma 3. Multiplying by 0.5 is just cutting in half, right? That makes sense. So B is at 8, comma negative 2. So what would the new point B be?
4, -1.
Good, 4, comma negative 1. Okay, C is at negative 4, negative 4. So my new point C would be
2, 2.
negative 2, negative 2. And then D is at negative 4, comma 6. So that would be negative 2, comma 3. Right? Okay. Then it says, show that the distance between A and D is half the distance between A prime and D prime. Okay, here's the thing. We should have to break out like our whole distance process, right? Like subtract the x's, subtract the y's, do Pythag. Okay? Why could I get away without doing that here? Jay?
Would you just be able to like write down both coordinates and just say like x times 2 equals.
Well, it kind of wants you to show that. It wants you to show that, like, if you find the length between these two and the length between these two, the lengths come out to be half of each other. But what could be an easy, look at the segment it's asking you to work with. Matt?
Isn't it, since it's just like full units, we just count the units?
Yeah, well, because it's horizontal, right? It's like straight across. You don't have that diagonal thing where you have to do Pythag. Okay? I could just say, well, the length from A to D is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And then I would just maybe say that I counted it on the graph. Okay? And then the length, let's see, A prime would be at 3, comma 3. And D prime would be at negative 2, comma 3. Okay? So from there to there is 1, 2, 3, 4, 5 units. That would not work if that were a, like this segment, like AB. I would have to make the triangle and do Pythag. But because that's straight across, I can just show it from the graph. Okay? And then maybe I would say something like 5 is, because it wants you to show that it's half of the distance, so 5 is half.
It says to show that AB is half of A prime D prime, but that's not.
Oh, you're right. That's a typo. Yeah, that should be written the other way around.
Okay.
This should be half the distance of that. Yeah. Thank you for pointing that out. I'm going to make a change in that. Because that's not what should have happened anyway. Okay. That make sense? Okay. What else you want to see?